My name is César Esteban.
And you are working for which company?
Yeah, I'm field application engineer in automotive for KDPOF.
Okay.
Knowledge development for plastic.
And KDPOF stands for?
Knowledge development for POF, which is optical fiber.
And you are developing optical fiber for cars, in-car application?
Not exactly. We are developing optical transceivers for cars, not fiber. We have partners who are suppliers of the optical connectivity, which I mean optical connectors, optical cables, but that is supplied by our partners. But our product is the optical transceiver, the electronics, the chip.
And is fiber optics already in cars today? And how will the future look?
Of course, optical fiber is present in cars today. There are European OEMs that have, for example, for battery management system, they are using optical fiber at 100 or at 1 gigabit per second. Yeah.
Nowadays. Already.
Nowadays on plastic optical fiber.
And how will the future? Will there be advancements?
Well, for the future, it's almost here. We have developed a new technology that we have standardized under IEEE. The 802.3ZZ is the standardization group, and we have developed the transceiver for the lower bit rates of that standard, which covers from 2.5 up to 10 gigabit per second. Okay? That technology is based on glass optical fiber, so we have moved from plastic to glass optical fiber.
Real glass?
Yeah.
Is it more expensive, the glass?
No, it's not. It's not. It has a massive economy scale, and it is the type of fiber which has which is in production all around the world for other markets, the multi-mode OM3 fiber, and it's a very low cost.
Can you compare the glass with the copper that we had so far?
Yeah. Optical gets more and more advantage as we move up in bitrate. So when we are in the 10 gigabit per second or even higher bit rates, we have a simpler solution than copper because the response of the channel is completely flat in optical up to more than 10 gigahertz, while copper is having an important attenuation with the frequency and has some aging effect, and optical does not have to compensate this effect by equalization. So we have simpler physical layer, which means lower power consumption, lower latency, and most important, lower cost for our solution. Of course, with the cable is lighter, is more flexible than the copper cable that is used for multi-gig, and in general we have a more efficient solution. We can also talk about EMC and signal integrity, galvanic isolation. All are advantages except one thing, which is the power supply. The power supply in optical needs an hybrid cable to convey the power over the cable, while copper could use power over data line. But the rest of the comparison is always an advantage for optical.
So where would be the cost break even? At which speed? Can one tell? Is it at 1 gigabit or 100?
No, it's multi-gig. I mean, from 2.5, 5 and 10 gigabit, we are breaking the cost compared to copper.
So it is more economically to use copper?
Definitely, and as we move to higher bit rates, the difference will be higher.
So it will be normal that we see more fiber in the car in the future.
Yeah, we will.
Why do cars need so much speed? Can you tell one or two applications?
Yeah, well, the most important application is ADAS, advanced driving assistance, where sensors are requiring more and more bandwidth. Cameras, radar, also the displays are requiring more and more bandwidth and bitrate. And also with the sonar architecture, now we are having the backbone are implementing what we call sensor fusion. So the data coming from different sensors all around the car are fusion and transmitted all around the backbone. So the backbone is required to have higher bandwidth than some years ago.
So you need it not for entertainment, but for all these intelligent in-car applications.
Entertainment is another use case that is requiring more and more bandwidth, but it's not as critical as ADAS.
Critical in terms of speed, or in terms of
real-time?
Real-time.
Yeah, real-time traffic. For ADAS, you need the data coming from the sensors have to be in the ECU to be processed in a very little time, very short time.
Yeah.
You need to transmit a lot of bandwidth in a very short period of time. So for this kind of applications, it's really, really critical to have a technology that is able to transmit very high bandwidth with optical.
So you are not producing the cables, you are producing the
transceiver.
The cable is not critical. The cable does 50 gigabit.
It's also important, but the good thing is that the same cable and the same connectors will be used for the different bit rates from 2.5 gigabit per second up to 50, and in the future 100, 200 gigabit per second. The same cables, the same connectors will be reused, which is a very good thing, because copper has to update the category of their cables as they move to a higher bit rate. So we stay with the same connectors and cables for all the bit rates, because it's the response of the multimode OM3 glass fiber is flat for all the bandwidth we need for all these bit rates.
So the cheap ones is plastic, and the better ones is glass cables. Where's the switch?
It's hard to say about the cost, because both of them have a lower cost. It is true that glass optical fiber benefits from a higher economy of scale, because glass fiber, multimode glass fiber, is produced by millions and millions of meters for other applications, and that could be a good point for glass fiber compared to plastic optical fiber. And the technology has evolved that much for glass fiber that all the requirements in terms of harsh environment, mechanical stress, chemical loads, all these things have been solved. And now we have fibers in glass that can comply with all the requirements of automotive, bending, mechanical stress, and so on.
Can you say something about your company? Where do you come from? Where are you located?
We are based in Madrid, in Spain, but we have a presence all around the world, and we have also people developing, working remotely all around Europe as well. So we are present. We have presence all around the world. Basically, we have several gigabit links over plastic optical fiber running. All of them are connected to this Ethernet switch that we have developed with a partnership with NXP. And one of the links
is a fiber switch here.
This is a fiber switch. We have the KDPOF transceivers here, our transceivers, and this is a couple of NXP Ethernet switches. Okay?
So Ethernet goes to fiber and to copper? No different?
You can choose. I mean,
Ethernet is Ethernet.
Automotive Ethernet can have copper PHYs, but also optical PHYs.
But this switch can only take fiber.
Well, we have assembled optical transceivers here, but there is also a version of this board that is with copper PHYs, as the interfaces with the switch are exactly the same in optical than in copper. The replacement of one technology by the other is immediate.
And what do you show here as a whole?
Yeah, we have several optical links. One is this mini PC is streaming high definition video, and it's getting to one of these ports, and then it's going through the switch, and then it's transmitted at 1 gigabit to another mini PC, which is displaying this high definition video.
Okay.
And in parallel, we are running traffic with this traffic generator equipment. So we are generating with these two test ports bidirectionally. We are generating traffic and receiving on the two ports, going through the switch as well.
There are two different cables. Yes,
they are basically the same. They are step index, plastic optical fiber cabling.
Okay. And what we see here, is it already used in cars?
Yeah.
This is used?
It's in production and it's
at a speed of 1 gigabit normally.
Or 100 megabit.
But you would not tell the car makers' names that use it, or can you?
Unfortunately, I cannot disclose that information.
So one would ask the car makers themselves for this. Okay. Thank you very much.
You're welcome.
We had this conversation at the Automotive Ethernet Congress. It took place this year from March 21 to 23 at the Hilton Munich Airport Hotel. Great organization by Katrin Scheinig, Director Events at WEKA FACHMEDIEN on the left, and Alexandra Feuerstein, Events Officer at WEKA FACHMEDIEN on the right. The Congress was very well attended. The conference capacity of the Hilton Munich Airport Hotel was right at the limit. On March 22, the weather was so nice that some guests even spent their lunch break outside in front of the hotel. For guests from afar, the Hilton Airport has very short distances. During the day, you can see the airport directly from the hotel's lobby through the huge glass window of the reception hall. And even at night, you don't have to look far for the airport. Terminal 2, on the left in the picture, is only a few meters away on foot. Thanks for watching this video and all the best until next time.